All right, welcome back. It's been a while, and I was cleaning out some parts, and I had a VTEC solenoid that I was going to refurbish. So I figured I'd make a little video and just show you how I go about doing that. And as I thought about it and I got prepared to do this video, I started going down the rabbit hole of maybe showing people a little bit more about how the VTEC solenoid functions and how it actually makes your VTEC work. So I think we're going to do that. So in front of us we have an H22 cylinder head, and we have the VTEC solenoid, which is right over here. This is what we're going to start with, and then we'll talk a little bit about the function of the VTEC as we go through the video. But if you're looking at your car from the hood into the engine bay, you will see the VTEC solenoid on the left-hand side, which would be the passenger side of the vehicle here in North America. So this is what we're going to essentially be working on. I'm just going to show you how it comes off this head, and then we'll start taking it apart. But I had a spare head, I pulled it out, put a few things in here. I'm going to show you a little bit about how the VTEC controls the oil flow and how that engages the actual VTEC cam lobe. So let's take this apart, and we will start working our way through rebuilding this VTEC solenoid. Okay. So we're going to flip the head around, and I'll bring it up so you can kind of see. That is what we are working on. So this solenoid has 3 10mm bolts that attach it to the cylinder head. So we are just going to pull those off. So if you're doing this on the car, you are going to get oil coming out the side of the head when you do this. So have a rag ready to clean it up. And if you're doing it on a warm engine, just be cautious. We don't want anything flammable happening, and we don't know where all that oil is going to go. Okay, so we don't need the cylinder head for now. We'll come back to that in a little bit. So let's just focus on the actual solenoid itself. So what do we have here? Well, we have these are the 3 bolts that hold it to the cylinder head. These are all M6 by 1.0, and if you're curious, they are 30mm underhead length. And there's 3 of them. So we'll just put those over there for now. Okay, so here is your VTEC solenoid. You have the actual solenoid itself is up here, which is controlled from a signal that comes through this wire, and we'll open and close that. And then you actually have the VTEC pressure switch right here, which will send the ECU information about how much pressure is actually contained inside of this body. Okay, so on this side, you can see that you have this gasket that goes in here, and you have this stainless screen that keeps debris from flowing through into the oiling system farther upstream into the cylinder head. So you can kind of find a corner and pull it out. And these things get super brittle and they break down and deteriorate. If you've never taken yours apart, this would be a great opportunity for you to clean out this screen just with some brake clean. You can use a stainless brush or a brass brush and some compressed air, but ultimately you just want to clean out this gasket and clean out that. And then once it's clean, you can put it back in, or you can buy a new one. So here is the body itself right there. And what I have done with the body that I'm going to show you in a minute, this one, is I've taken it and I have soda blasted it. So it's not essential, but when I get one, I like to clean them all up and then finish them and package them so that I have one spare if I need one. But let's continue taking this one apart. So we're going to take off just the bracket that holds the plug. Pull that off, get that out of the way, and then we will undo the solenoid itself. The solenoid itself is held on by 3 more 6M bolts. we will just pop those off. Again, you're going to get some oil coming out as you do this. These 10M bolts, they have an underhead length, if you're curious, of 18 millimeters. I know it's nice to sometimes know if you've got a box of bolts and you don't know where anything goes, if you actually know the length of the bolts. So there you go. Those ones are 18 millimeters underhead length. And if you don't know what that means, that is simply the length from the base underneath the head to the very point. Okay, so there is the actual solenoid. Inside, you can see this one has another screen. Now, depending if someone has worked on your car in the past, you might actually get one that doesn't have the screen in here. There are some manufacturers that produce these O-ring gaskets that do not have that central screen. I would prefer to use the screen, but if you get one that doesn't, it's not the end of the world. So you have oiling happening through this passage, and this solenoid is triggered, and that will allow it to open. It's normally closed, so when it triggers, it opens and it allows oil to flow through that passage and then down into the actual body that is regulating the oil from the pump into the cylinder head through the rocker shaft and then engaging your VTEC. So this we're going to clean out, but we'll talk about that in a second. So put that over there. So here it is. So in the top, you're going to find this little piece right here. And all this does is compress down the plunger in here and sets it at the appropriate height so that all the valves are sitting where they need to be. So it depresses it just a little bit to put it into its neutral position. So we're just gonna pull that out. Shouldn't be hard. Oil passes through that hole and then it goes down here into this cavity. So as the oil works its way down, it works its way through the passages and over to the actual rockers. So right here, I think if it's not jammed or seized, you should just be able to give it a tap and it'll pop out. In here, don't worry, there's only two pieces you need to worry about, and that is this plunger, this control valve, oil control valve, and this spring that just keeps it in its spot and returns it after the VTEC's been disengaged. So you just have the plunger, which has an open cavity in there, the spring goes in there, and then it just slides right back in there. Now, sometimes these do get jammed and they can be a bit of a pain in the butt to get out. If that is the case, I have two options for you. The first one is, and you need to be very careful when you do this, you can take compressed air and you can put a nozzle, hopefully you have like a rubber end for your compressed air blowgun, and if you blow air through there, it will push this up and out the top. Now, if you do this, you can shoot it out, and if you have your finger here, you will take the end of your finger off. So you want to do this in a very controlled manner, and generally I will push this up against, I'll push this piece up against like a block of wood, and then shoot air through there, and then it'll shoot up, it'll hit the wood, and then all you got to do is just kind of slowly roll this and shoot air through it until it will come out the top. And then it'll get to a point where the air is bypassing and it won't go any farther, and then you will be forced to use a small screwdriver or anything else you have. You can start with like a body pick or something that's not metal, but if you get it to the point where you can get underneath there, you can try and pry it up, and then you can grab it underneath here. Sometimes I put like a pair of pliers or a crescent wrench, a small one, and then just grab it and pull it out as straight as possible. okay, because you don't want to score. This is steel, you're not really going to wreck this, but you can score the inside of the actual body, and then it won't function nearly as well. They're pretty good, but you do have the potential to destroy it and hinder its function. So the body, the plunger, the spring, we'll take these pieces out. And then the last kind of component that you have on here is the VTEC pressure switch. And this is a 22 millimeter socket to pull this out. And it as well has an O-ring in there that should be replaced. And it just comes out of the body. So after you've got all of that apart, you have the empty body. There are some manufacturers that sell these, but the OEM Honda ones, especially the factory ones, you'll see it has that symbol on it right there. So if you're looking for an OEM one, you're looking for that. These work really well, and they're worth cleaning up and having a spare. So that's what we're doing here right now, is just showing you the disassembly of this, and then the reassembly of the one that we've cleaned up. So let's push some of this to the side, and then we will show you the one that I have started to clean up. Okay, so this is the one that I've already disassembled. I just moved the one we took apart up to the top here. But this one is the one that I've already disassembled to show you reassembly and the cleaning. So what I like to do with these, if you have access to it, is I have a cabinet that I use just for soda. And soda blasting is one of my favorite things because you can make old parts look like new. There are people who will tell you that using a media blast cabinet to clean internal engine components is a very bad idea. I understand what they're trying to get at, but if you're someone who's been doing it for a while and you understand the limitations and what can go wrong, you'll be perfectly fine. So, should you ever use glass or sand or any sort of coarse abrasive that is non-soluble? No, never. Don't do that. But if you get baking soda, you can blast these and they can come out beautifully. And you can do all of the areas. It's pretty gentle, but it's abrasive enough that you can clean off all of the old oil staining inside that cavity. You can clean up all of the surfaces that essentially function as like a bearing surface for the slide to go up and down, and you can clean out all the passages. So basically I put it in there and I blast it with soda, and then I put it in a parts washer and I clean it. You can use brake clean as well if you're not going to go to the extent of soda blasting them. Brake clean works really good. Parts cleaner, you can put it in there and let it soak for a while, and then take it out and try and blow it off as much as you can, or get a like a brass wire brush and just clean out all the cavities and push a wire through them until you get to a clean product that will work for you. But for me, soda is the way to go. So that's why I did this. So this one has been soda blasted. That cavity is all clean. I'll try and show you so you can kind of see all the passages. They've all been kind of cleaned up, and it makes the outside look really nice, like brand new. So I also do the plunger. So the steel, this machine steel comes up real nice. You can clean, you can see the difference. You can get all the oil staining off and anything that's stuck on there, and you get a really nice finish. Because sometimes you will get debris and just oil scum and buildup inside of those passages that makes this plunger really hard to move in and out. This cleans it all off and it works really well. I also did the spring. And then I also did the actual solenoid. Now this cap piece, which some people will get like a kind of an aesthetic sort of cap that goes on top. I have one actually, maybe I will show you that in a little bit. You can get one from Skunk 2, or you can get one from all sorts of different companies. It's not just one company, there's lots of them that make them. But this is steel, and this rusts, and it often looks not so great. And I think that's why people want to do that. The rest of it is a cast aluminum body and it won't matter. It doesn't care about the elements, but this does. So sometimes when I clean them up, I will tape that off and I will just spray bomb this with something just to keep the rust from coming back. Or you can do that and then place the cover over top, depending on whether or not it fits loosely or tightly. A little bit of spray paint goes a long way sometimes. So that's the valve. Now with this, I do blast all of the outside. I tape off the wire just to try and protect it from being blasted, but I do not blast the inside here. I try and block this off with some tape just to make sure no soda gets in there. And you do want to clean it out with brake clean afterwards, because the soda gets everywhere. But the beauty about soda is it's water soluble and it'll be soluble in oil as well. But try and get as much of it out as you can. You don't want it in there, though it will flow through after a while. But just clean it out with a bunch of brake clean, and that is the actual solenoid. The solenoid is the piece that allows the oil to flow from downstream, upstream into the cylinder head. And this is what gives you your VTEC function when the computer allows it to happen. So maybe we'll just put these on the table and we'll talk a little bit about the function and how the oil is used to engage your VTEC. Okay, now let's talk about a little bit about the function and what is going on here when we engage VTEC and what's going on inside this body. So we are going to just thread this pressure sensor back in for now. We're going to grab the plunger and I'm going to get a little oil. Just going to put a little oil on there. I'm going to take the spring, put the spring inside the cup. Take the plunger, push it through the top, roll it in. It should sit in just like that. There we go. So we have it in place. Now, to show you what happens, I'm just going to wipe my hand. So on the top, where we have that other piece that just seats it, we don't need that right now for me to show you this. I'm just going to take a screwdriver to show you this. So the oil is coming in from downstream into this passage right here, into this void. So it's sitting in here, it's pressurized, and it's sitting. What happens when that solenoid clicks over, when you have the conditions and they're right, is it will push this plunger down. And if we push the plunger down, you can see it open up. It opens up right here. That allows oil to move from this pressurized side into this side. So now you have pressurized oil in here. This pressurized oil then moves through the head into the rocker shafts, down the rocker shafts into the actual rockers, where it makes contact with, in the manual they call them the hydraulic piston A and hydraulic piston B, which sit inside the rockers, and I will show you them. But to just give you an idea of what's going on here, I think I can show you with some compressed air. So we'll just put that like that. I'm just going to grab my compressed air 1 second. I don't know how loud this is going to be for you, but we're going to put air through that top piece right there. And you should be able to watch that piston it go up and down. So that's essentially what's happening, is the oil from the engine is being forced down and pushing that plunger, which allows it to bypass into that upper cavity. I believe the pressure is somewhere between 50 and I think it's 57 psi is what the manual says to check for. if your solenoid is not functioning, and then you know you have a faulty solenoid. So somewhere between like 50 and 55 PSI is what's needed to actually get the system to engage. So that is what's physically happening inside of this when triggered. So what's triggering it? What's doing that? So in order for your VTEC to actually work, I'm just going to go off the manual. For the one that I was looking at was just my 94 out of the 4th gen. So you need an engine speed of over 4,900 RPM. You need a vehicle speed of about 30 kilometers an hour or more. You need engine coolant temperature above 140. And the actual trigger, which gets this moving, you need a higher engine load. So you can run your car on the low lobe. I mean, I'm sure you know, if you've driven one of these cars before, if you bring it on really slow, you won't engage VTEC. You can run it all the way up. But as soon as you stomp on it and create that high load, because you already have the conditions of 4,900 RPM, 30 kilometers an hour, coolant temperature, as soon as you give that load will trigger this solenoid, which will open, push the plunger down, move the oil from here to here, and shoot it through the actual rocker shafts. And that's what will get you to the point where we engage VTEC. So I think what I'm going to do is show you how that functions from here into the cylinder head. Okay, so what we have happening here is, like I showed you, the oil is coming in and sitting here and then bypassing up into here when VTEC's engaged. So here is the oil passage that has oil pressure right here. That's running through the head, down here, down the side, and into the block. It comes up just by where your oil cooler, oil filter are. So that's the main feed that comes up across the head, into here, through here, pops out here, so you have oil pressure, full oil pressure into that VTEC solenoid housing that is sitting inside right here. When that plunger is depressed and triggered, that oil then moves up into here. This is the access point for your rocker shaft. So you have a rocker shaft here on the intake side and a rocker shaft here on the exhaust side. Now the oil pressure goes through here, splits, and then goes down those rocker shafts. As the oil goes down those rocker shafts, it encounters all of the individual rockers that ride up and down along the camshaft. So I think I'll move things again a little bit, and we will then show you what happens next as that oil makes its way down the rocker shafts to the rockers. So let's get repositioned. Okay, so we have the head rearranged in a position where you can see everything now. So we've met all the conditions for the ECU to engage VTEC. The solenoid has been tripped. We've pushed that plunger down. The oil has come up. It has moved from here to here, and now it is going to move into the head. It's moved into the head. Now it's going through these two rocker arms. I have one in place that I'm going to show you where it goes next. So this is the exhaust rocker arm, and rocker arm, it's the shaft. So the rocker shaft, and the oil is now pressurized and flowing through the shaft to all of the individual rockers along here. So I have a set in here so you can see them, but I will pull out another set so I can show you them individually. So these are broken up into three. You have the primary rocker, then you have the mid rocker, and you have the secondary rocker. This is your VTEC, okay? So what's going on here? So in here you have an oil passage, and that oil passage lines up with the one on the rocker shaft. And these all line up, like you can see over here, sitting on there. The oil will come in through the rocker shaft into the primary and then flow through. And inside here they have what's called hydraulic piston A and piston B. Now these are tucked away inside of these rocker arms. So you can see this one, there's a cavity in there. This is piston A. Piston A goes in this rocker arm and sits flush like that. Then you have piston B, which is larger and longer, and it goes on the, they call it the mid rocker arm, but it's your VTEC one. And it sits in there, and it also sits flush on both sides. And these go up against each other. Then the last one that you have is the secondary rocker arm. Now this one has a spring-loaded piston in there, and you can push it, and it pushes in and out. So that functions to disengage your VTEC. So these all lock together like that, and they ride up and down on that rocker shaft, as well as the camshaft on the individual lobes. So when they're functioning independently, you will have these moving with the profile of the camshaft. And this middle rocker, the VTEC one, will ride up and down on the lost motion assembly, which I'll show you in a second. So what happens when you meet all the conditions and the oil pressure is firing down that rocker shaft is it goes in here and it pushes that little piston right there out. So I'm just going to push it out a little bit with some compressed air so I can show you. This is going to be... So the oil pressure pushes that piston A out, which then locks to, let's see if I can do this without, it's going to be a bit of a fight. 1 second. This is going to be a little more exaggerated here. So it's going to lock to there, and that will push out piston B, which will then push into there. Now this one won't because it has a spring-loaded function, but it basically locks all three shafts together. So you're no longer using your primary and secondary lobe, you're only using the mid lobe, which is your VTEC lobe. So that oil pressure has moved that, and it skewers them. That's actually what the manual says. So it takes these three rockers and pushes a pin through and skewers them all together. So they are locked, they are functioning as one. So let's look at that in the head. So in the head, right here, that is these. They get skewered together, they're locked, and you will only be riding on that center lobe. That will be in total control. Underneath there, it's hard to see, but you can see a lost motion assembly, which in the older models, it looks like these. They're like a hydraulic one. A lot of people like to replace these with a spring style that came in the newer one, or you can get them online. Skunk 2 makes them, and that will be what the VTEC lobe rides up and down on. Okay, so yeah, that got me thinking about showing you the two different styles of lost motion assemblies. One comes from the newer 5th gen Prelude, and one comes from the older 4th gen. So we have the older 4th gen assembly right here. This is a hydraulic functioning one that has a spring in there as well, and it has an outer casing. This one is in the 4th gen. Then we have the beehive wound spring style that is in the 5th gen Prelude. This one's actually made by Skunk 2, and it is a wound spring. It doesn't have the outer casing, and it's not using any sort of hydraulic function. So I've never really had a problem with this older style functioning one, but I have heard about issues with people running larger camshafts having an issue, and I believe it's because of this style. And the reason I say that is because if you're using this style of lost motion assembly, you can see the, no, it's not scoring, the staining up top here on the outer shell of this casing. This portion is inside the casting of the head, and this portion is protruding outside of the head. And then you have the rocker, which is riding on this, pushing this in and out. Well, if you have a very high lift camshaft, this is going to bottom out and potentially hit the outer casing of this style of lost motion assembly. Whereas with the Wow and Beehive one, you can push this all the way into the factory casting before you're going to make any contact with it. Which means you get to have about 6 to 8 more millimeters of lift if you were going to go that far before you have an issue of binding or interference. And if you're having even a little bit of interference, you're going to send metal into the engine. You're going to have a whole bunch of issues. So if you're going to run a high lift camshaft more so than stock, you should probably consider switching out your lost motion assemblies to these, because I would contemplate that that's probably one of the issues that those people are facing. I haven't actually clearanced one myself, but that is my guess. So those are the lost motion assemblies. That's what the rocker rides up and down, the VTEC rocker, and deals with that motion as the camshaft is turning. So let's put these off to the side, and we are going to look at the camshaft itself now for a second. So we're going to put the camshaft on top of those rocker pads. And so you have the primary, the mid, and the secondary, the mid being the VTEC lobe. And now that we have engaged VTEC, we've locked all those rockers together. They're functioning as one. These are no longer being contacted. Just the central lobe is being contacted. So I'm going to reposition, and we can look at what the VTEC lobe looks like and how it functions differently than the primary and the secondary. So let me get repositioned. All right, let's take a look at Honda's masterpiece just for a quick moment, because we are supposed to be talking about oil control valves, not about camshafts. So this is Honda's H-Series VTEC camshaft. It is similar to all other VTEC camshafts that Honda has produced. You have the primary, the mid, and the secondary lobes. So this is how VTEC functions. It gives you 2 different profiles on one camshaft, and it's controlled by that oil pressure that we've been talking about with the solenoid. Now, ultimately what that does is give you a power band of idle to 5,000 RPM on the low lobes, and from 5,000 to as high as 10,000 on the high lobe, though that's not a factory one for the H-Series. This system is incredibly complex, yet beautifully simple and incredibly reliable. And that's not something that many manufacturers knock out of the park very often, even Honda. But they have, and it has been functioning so well for so many years. It just is very expensive to produce, and that's why many of their modern cars are starting to move away from it. And most modern cars are moving towards turbochargers. It's just what's happening. But this system is beautiful to me. And let's take a look and see what we're actually getting. So if we look up here, we can see the secondary lobe, the VTEC lobe, the mid, and the primary. So when we move off of the primary and the secondary onto the VTEC lobe, hopefully you can see that. I'm trying to find a way to get there. Okay, so you can see that it has a different ramp. That's just how the cam comes on. It has a different lift and a different duration. And that's because in order for a internal combustion to function at a higher RPM, you're essentially it's just a big air pump. You're moving air in and out. And the faster you do it in an internal combustion motor, you need to get that mass in and out quicker. And it becomes harder and harder to do with a short window. And that's why you have this secondary profile. So yeah, you essentially get to the point where you can allow your motor to function in 2 different environments, a low speed one and a high speed one. And Honda has done this masterfully. So this is the VTEC camshaft. That is the lobes that control this function. And I think that now we will pop this back in there and I will show you the assembly of the oil control valve and putting it back on the head now that we've completed this task. All right, well, like with every other video I've made, this has taken longer than I expected, mostly because I seem to get sidetracked by every shiny thing that I see. So I've already showed you how to take this solenoid apart, and I've basically shown you how to put it back together, all the internal pieces. You probably have a pretty good idea of how it goes together at this point, or you should. So we're going to put this together pretty quickly and attach it to the cylinder head. So we are going to take the plunger, a little bit of oil, and take the spring, put it in the plunger, grab the housing. We've cleaned this out. It's perfect. It's ready to go. So we're going to work it in there with the oil, push it in, make sure it moves freely. This one's been completely cleaned like you've seen. I'm going to take that top spacer piece. We're going to put that on top. It moves good. Let's clean this off. Then we are going to put that down for a second. We will grab the solenoid, which is where our journey began, and I'm going to grab one of these gaskets. This is one of the ones I was talking about. It doesn't have the filter on it. I will probably replace this later on. If this is all you can find, it'll do. But if you can find one that has that extra screen, that would be preferable. So after those are ready to go, we're going to put those two surfaces together. You can just hold it. We're going to take our 3 bolts and we'll just get them started. Make sure you get them started and don't cross thread them, because these housings will strip. You don't need to use a ton of force on this either. I'm just going to tighten them. If you're doing that, you can do it with just a wrench, or you can do it with a torque wrench and they get torqued to 9 foot-pounds. I would say just put a wrench on it, tighten it until it's tight. And then when you fire it up and start it, just make sure there's no leaking around here. If it's leaking, tighten it some more. You don't want to strip those. Okay, so now that we have the solenoid attached to the body, the plunger, and the spring in, we will put the screen and the gasket on this one. So this is one, and almost all of these come with a screen. If this doesn't have a screen, get a different one. You need a screen here. So we're just going to push that in. Now, if you're going to put this onto your car and it's not sitting on a bench like this, you potentially might need to put a little bit of grease in the corner to hold the gasket in place. That's a little trick you can use if you're fighting it, trying to get it on there. So put that in. Then on this side, we are going to put the VTEC pressure switch back together. We're going to use that O-ring, put it in, seat it, and then you can torque this to 20 foot-pounds, or you can just simply tighten it till it's snug. Again, these are things that they don't have to be exactly that torque, they just don't have to leak. So tighten them snug, try them. If they leak, tighten them some more. Don't risk stripping these out. Okay, so there we go. We've got that fully assembled. We are now going to take this and put it back onto the head like you would be doing. So just make sure it stays there. Make sure it goes up against there nice and flush, and there's nothing on that mating surface, and you've cleaned that mating surface. Then we're going to take those other 3 bolts that we've already identified earlier in the video. We can start them until you get them going. And then once you have them started and not cross-threaded, you can zip them in. Okay, so now we have the VTEC solenoid reassembled and back attached to the cylinder head. Excellent. I figured I'd close this off with that cap that we talked about for a few seconds. So I found one. I had one sitting around. So this is a Skunk 2-1. And you might find that this body is too small for this case. I don't know why they don't make it tighter. It's a silly thing. So creative use, it's not stupid if it works. 2 pieces of pop can cut, and you just take it and you put it inside here, because it is a very loose fit from the way it's designed. I don't know why. You could try and glue it on there, but 2 of these pop can pieces work really good. I normally, again, I will prime this with some paint so that it doesn't rust, because this is steel, and that's really the only reason I would put one of these on, is because these rust. So once you've done that, you can take it and you can kind of just work it around and then just push it all the way down. And then that really shouldn't come off. It's a pretty snug fit. You can adjust it by using more or less pop can layers. Okay, so there it is. We fixed that ugly thing at the top, and we have rebuilt that solenoid. So now there's nothing left to do other than let VTEC kick in. So thank you for spending your time with me. I hope that you've learned something. I know we got a little off track. Hopefully you learned a little bit about how the function of your VTEC actually works. And you've rebuilt your solenoid, you've cleaned out those filters, and it's good to go for many years to come. So thanks for hanging out with me. I really appreciate it. All the best, and keep those classic Hondas rolling.